Today's lesson is called More Inequalities, Special Cases. So in example 1, solve the following inequality, express the solution in graph form, interval notation, and set notation. So remember, we solve an inequality using the same steps as for solving a linear equation. I see distributive property, so that should be the first thing that I simplify. So I end up with 2x minus 24 is less than 4x minus 8. Make sure you distribute to all the parts. Then I would look to combine like terms, but I don't have any like terms on the left, and I don't have any like terms on the right. So I go right to variables on both sides. I'm going to get rid of the 2x, which is positive, by doing the opposite, which is subtracting. So I get negative 24 is less than 2x minus 8. I'm then going to undo my subtraction by adding. So I end up with negative 16 is less than 2x. And then I would have to divide by 2 in order to get x by itself. So negative 8 is less than x. No need to flip or switch the symbol. We never divided or multiplied by a negative. So I am going to rewrite it the way that we feel is more friendly, which is the variable first. Make sure the inequality still remains true. So we're looking at x is greater than negative 8. So in graph form, I will make sure I have negative 8 in the middle, give a couple above, and give a couple below. Then circle, x is greater than negative 8. So that means negative 8 is not included. So I'm going to put an open circle on negative 8. And I need all the numbers that are greater than negative 8, which means I'm shading to the right. For interval notation, if I look at my graph, I can see that negative 8 is my lowest that it's going to be, and then everything else is going to be greater than that. So when I write my interval notation, remember I'm going to have two numbers, so negative 8 is my lower bound, and it's going to go towards positive infinity. There's always a set of open brackets next to infinity, since it goes on forever. And then negative 8 was not included, so that also has a set of open brackets or parentheses. For set interval, we're going to make our curly bracket to show that it's going to be the set of. We're going to do x such that x is less than negative 8. Okay, and therefore we've hit all the requirements of that question. Moving on now to example 2. Here's another application of how inequalities could be presented to you in algebra. It says determine the smallest integer, that's important, that makes negative 3x plus 7 minus 5x less than 15 true. So we need to solve this inequality. First I look for a distributive property, and I don't see any. Then I'm going to look for like terms on the left, and I see that negative 3x and negative 5x are like terms. So if I combine those, I get negative 8x plus 7 is less than 15. I would then look for variables on both sides. I don't have any, so I'm going to undo my addition by subtracting. So I'm going to get rid of that adding 7 by subtracting 7. So I get negative 8x is less than 8. Then I'm going to try to get x by itself. This is a multiplication problem right now, so I'm going to undo multiplication by dividing. Always make sure you divide by your coefficient. Symbol, alarm, we just divided by a negative. So this is one where we have to switch or flip. So these are going to cancel, and I get x is greater than negative 1. Okay. So looking at this, it's important to remember that negative 1 is not included in this answer. I know that because it says x is greater than negative 1. So even though the question did not ask us to create a graph, I think a graph is a very helpful way for you to determine the answer to a question like this. They're still asking me what's the smallest integer that makes this true. And negative 1 isn't included, so negative 1 cannot be our answer. So let's use the graph to create a picture. I'll put negative 1 in the center, do a couple above and a couple below. We'll draw it out and it'll help us answer the question. So if -1 is not included, that's an open circle. We want where all the numbers are greater than -1, which is this way. So now when they ask me to determine the smallest integer that makes this true, I know -1 can't count, but the next smallest is right there and it's 0. So use the number line to help you with questions like smallest integer or what you're going to see in example 3, which is largest integer. So in example 3, it says given 2x plus ax minus 7 is greater than -12, determine the largest integer value, so largest integer, of a when x equals -1. So what's different about this inequality is you can see that there's some substitution that has to happen. We have two variables in the inequality, which means we cannot solve it. You can only solve this if there's one variable. But the way we get around that is right here, they want us to substitute -1 in for x. So let's make a little note up here that we should be substituting. Okay, so that inequality is now going to be 2 times, every time I see x, I'm going to put a -1 in parentheses. So a -1 here, here. Now there's my new inequality. So 2 times -1 is -2. A times -1 would be -a. Then we still have -7 and then greater than -12. So I look for distributive property. I don't have it. But on my left-hand side, I do have like terms. -2 and -7 should be combined. So this is -a minus 9 is greater than -12. I'm then going to undo my subtraction by adding. So I'm going to add 9 to both sides and get -a is greater than -3. I don't want -a. I have to have a by itself. So there's really a -1 in front of that a. So I should be dividing both sides by -1. And again, an alarm should go off. We just divided by a negative number, so we need to switch or flip. Okay, so that means this is now a is less than 3. So again, it's not saying you have to graph it, but the reason we use the number line is to help. So just going to be a nice little reminder there, use the number line to help. Okay, so even though they didn't ask us, let's go down here and put the number line together. 3 in the center, couple above, couple below. Let's think about the circle. So a is less than 3 means that 3 is not included. So I'm going to circle that 3, and I need to shade all the parts to the left of that, all the smaller ones. I'm not filling in that circle again because 3 is not included. So now when they ask me to find the largest integer value, I can't choose 3 because 3 is not included. So the next largest one out of this problem is going to be 2. So my answer is 2. That's the largest integer value of a when x is -1. And now lastly, we'll solve example 4. It says solve for x algebraically. And then it says, if x is a number in the interval -2, 2, state all integers that satisfy the given inequality. Explain how you determine your values. So first, let's take care of the first thing they asked us to do, which is solve for x algebraically. So I'm just going to copy my problem down here below. I'm going to follow all my same steps for solving an equation. So I'm going to look for distributive property. I see it, so I'm going to take that -2 and distribute it through. I get -2x plus 10 is less than 10. Then I'm going to undo addition or subtraction because I do not see any like terms, nor do I see variables on both sides. So I'm going to get rid of adding 10 by subtracting 10. And I get -2x is less than 0. Then I do not want -2x, I want x. So I'm going to divide both sides by the coefficient, which is -2. And as soon as I say that, I just divided by a negative. We have to switch or flip. So this is going to be x is greater than 0. So it says if x is in the interval -2 to 2 with squared off brackets. The squared off brackets means that the numbers I am choosing from include -2. And it says it's the integers in that interval. So negative 2 is included and 2 is included because of the type of bracket that was used. So we're picking from negative 2, negative 1, 0, 1, and 2. Again, because the negative 2 and 2 are included based on the way that interval notation is written. So, in the given interval from negative 2 to 2, including those two numbers, the integers, now let's look. X has to be greater than 0, which means 0 is not included. So out of that list, the only numbers that are greater than 0 are 1 and 2. So in the given interval from negative 2 to 2, including those numbers, the integers 1 and 2 satisfy the inequality because they are greater than 0. So we wanted to take time to show you some of the special ways that you could be asked to solve inequalities and apply inequalities, and all the kinds of different ways they can ask you to take it a step further, such as writing it in interval notation, set notation, having to come up with the smallest integer, the largest integer, as well as being able to look at an interval and tell which values in that interval satisfy the inequality. So that concludes our lesson on more inequalities, special cases.